I'm Dr. Stuart Eves and I work for Surrey Satellite Technology, where I'm one of the people who describes himself as an ideas guy and tries to think up new missions for satellite systems. I began my career studying astrophysics and then got a job working for the UK government looking at military space systems, and did that for the first 16 years of my career. I then moved into industry with Surrey Satellite Technology, and I've also spent some of my more recent career also working in industry for Airbus Defence and Space, where I've been looking at the designs of novel satellite systems to do surveillance, but also other functions like communications and navigation. Some of the recent work that I've done has been looking at trying to move what SSTL is currently able to do in terms of disaster monitoring. So we are operating a constellation of satellites that try to help people who've suffered some sort of major adverse effect, like an earthquake or a tsunami wave. But that's always after the fact. The bad thing has already happened. One of the things I'm most interested in at the moment is whether we can use satellites to perhaps forecast earthquake events, and I've been working with NASA in the United States to see whether there are actually signatures that could provide us up to a week's warning of an earthquake event using signatures that we could measure using satellites, so it would move us from disaster monitoring to disaster mitigation. I suppose one of the things that makes me want to look towards the future is the sense that we are discovering new things all the time. I'm definitely an ideas guy. I'm motivated by new knowledge. We are getting that about our own planet, but we're also learning new things about our backyard. We're learning new things about the solar system all the time, and there is considerable potential in robotic exploration of the solar system to tell us a lot more about not only the current situation of our solar system, but where it was in the past and where it might be in the future. One of the major changes that's happened over the last 20 years is that we've been able to benefit from the changes in the microelectronics industry down here on the Earth. So if you think about the way that laptop and PC computers have proliferated and the internet has changed the way that we live down here on the Earth, those same sort of changes are happening to our satellite systems. We've been able to take the same sorts of advantages in imaging technologies and memories and processors onto our satellites and enable our satellites to do an awful lot more. And we are essentially developing the PCs and the laptops of space now, rather than the mainframe computers of space. One of the major changes that I anticipate over the next decade is a space sector increasingly dominated by commercial considerations. If you look at the history of what's happened in space, for a long time it was mostly about national prestige, so it was governmental programs that were largely driving the developments of technologies and capabilities. Very much more now, as a company, we are getting our custom not from national governments, but from commercial organizations who can see a business case to do something in space and who can see a way to make a profit out of spacecraft. And that's the major change that I think we'll see over the next decade, is a lot more capability in the commercial sector rather than the governmental sector. I guess you might expect me to say this working for Surrey Satellite technology, but I'm a major fan of the robotic exploration of the solar system. In fact, I've done lectures in public previously discussing the relative merits of robots versus astronauts. I'm a big fan of the robots because in particular they're likely to get to a lot of places in the solar system before I die that human astronauts won't, and I'd like to know more before I get to that point than I would if we relied on manned exploration. We might learn a bit more about the moon by the time I die. We won't learn anything about anything further afield in my view, unless we send robots there. I won't go to Mars unless somebody sticks some of my ashes into an urn and fires it there, but I don't think I particularly want to. If you look at Mars and some of the marvellous imagery that's been generated by some of the orbiting spacecraft, there are all sorts of interesting terrain types on Mars. I would like to visit all those different terrain types with a fleet of exploratory rovers, rather than sending a single manned mission to explore one particular place on Mars, which is what you might do with the same amount of money. I'm not a particular fan of sending humans to Mars, and I think even the people that are concerned about the possibility that, or albeit a slim possibility, that there might be life on Mars and that we might contaminate it if we were to send a spacecraft there. So one of the things that I think demonstrates the degree of confliction in the people that are advocating manned exploration is that there was a recent report that NASA has found convincing evidence for water flows on Mars, albeit very briny water, but they are convinced that just occasionally, as a result of seasonal changes, water flows on Mars. And what has been suggested is that the next rover will not go anywhere near those water seeps for fear of contamination, which I think demonstrates the problem that, we are worried about contaminating, and if we're worried about simply contaminating with a rover, how much worse would the contamination problem be if we sent people to Mars? I think technology presents challenges, but I think it also offers solutions. The thing that I would most like to see is a viable way of protecting our electronics in orbit. One of the risks to SSTL's sort of business model is that the terrestrial microelectronics market moves to devices that perhaps have such small gate sizes that when you put those devices into space, cosmic rays don't just cause single event upsets, which you can deal with in software, but starts to cause single event damage. So if you get a cosmic ray passing through your electronics device, and it's very hard to shield those cosmic rays out, they have so much energy, that the device starts to actually degrade in the radiation environment in space. I think we will need to try and make sure that we've got a protection against the cosmic rays as the technology on the Earth advances. So it's more of a risk to our business model than a fear of any particular technology in particular. One of the things that I think we frequently lose sight of is that space is what would be referred to as a global commons, a bit like the air around the Earth or the oceans. So it's kind of the property of all mankind, if you can make that statement. And the thing that I'm very concerned about is that we're not preserving the global commons. We're putting a lot of space debris, particularly into low Earth orbit, and if we don't do something to clean up our act, then we won't be able to put satellites in low Earth orbit, and all of us that are interested in space will start to go out of business because you can't effectively do operations in low Earth orbit. So my advice would be embrace space traffic control, start dealing with the debris problem to preserve the global commons so that we can all exploit it and use it to our benefit in the future.